in a remote sensing application that LEO satellite use, because a satellite takes a 90 minutes of what, 90 to 100 minutes of for a rotation. Means every 90 minutes of a rotation, the satellite will reach at that particular point after 90 minutes. Means this particular area coverage, earth area coverage, because the satellite rotating, so for each rotation of this particular satellite, because this rotation will be around the earth, the satellite will looks with a different angle. Means area coverage right now supposed to be present is here now. Suppose satellite position is here, area coverage will be different. Suppose satellite position is here, the area coverage will be different. So now at every position, when the satellite is rotating, so area coverage by the satellite is a different. Means a satellite will looks at a different areas on the earth while rotating around its, okay, around its axis. Okay, this is about your satellite rotation. Even if earth is rotating, that is a different part. Right now we say that while rotating the satellite, it cover the different area. Means supposed to be for this particular area, I am saying, so satellite will reach after every 90 minutes. Means whatever the change occur in that particular region or particular area can be captured by the satellite. Means what? A satellite scan, okay, satellite scan complete earth. Okay, that is about, you can say that is about a scanning of this complete earth, that particular region is complete earth by the satellite while it is rotating around its axis. So that area coverage by the satellite is depending upon, or you can say that this particular width is depending upon that what are the various sensors, what are the various sensors used on this particular, on this particular satellite, or what are the various cameras or sensors, we can say that, that will be used in this particular satellite to capture that area, to take a photos. Okay, we can say that capture the photos, or we can say that it's about the images of this earth. Okay, to capture the area, this particular area of this earth. Which generally we can say that, so say that, suppose this is about your flat surface now. So satellite will capture this area in one rotation, in another rotation, you can say that this will be captured. Okay, in another duration, it will capture likewise. The satellite position is changes, so that area coverage by this satellite or taking a capturing the image is a different. So while getting the image, we are getting the image likewise. One then another one likewise. So windows will be multiple windows. Okay, we will get that a multiple windows there. Okay, means we are getting the various strips of this image, or we can say that that particular strips of this image, and that will cover this particular region, a whole earth. Okay, a whole earth region. So that resolution of that particular image, or we can say that whatever the data we are receiving, that is depending upon that resolution of the camera, or we can say that whichever the sensors present in the satellite there. So different images are captured at a different points. We can say that it is depend on different camera, the various cameras can be used to capture the particular image, so that we can say that the various spectral bands to be used here. Okay, we can consider that images to be captured with a various spectral band with a multiple time, so that we'll get that a multiple capturing image. Okay, we will get that multiple images there, and that multiple images to be used in applications such as, you can say that, applications like agriculture. Okay, we can say that, applications, or we can say that is about a military there for the navigation system, or you can say that a water management system, or a checking of the flood and all. Okay, or any urban area development, that is about to develop the smart city and all. We need to get the images of that particular city. So we can say that a development of that particular region, or you can say that environmental study, or you can say that a forest study, or we can identify that what about the flood, or any disaster management. So we can use this particular remote sensing satellite there. And that remote sensing satellite, if you see that it was launched actually, if you see that in Indian government, so ISRO has launched a various satellite that is used for the remote sensing purpose. So there are the various tables. If you see the table, so that various tables are available for this particular remote sensing satellite. So you can check, we can say that PPTs. In a PPTs, maybe a remote sensing satellites are there that was launched by the ISRO there. For what purpose one table is there? Okay, so that are the applications of a LEO satellite to be in a, we can say that, for the remote sensing purpose. Next about a medium Earth orbit. Sorry, medium Earth orbit. That is, we can say it is about a MEO orbit. And that MEO orbit, so it has a altitude. That altitude of what? A 10,000 kilometer to a 20,000 kilometer. That is about a MEO orbit. So it has a what altitude of what? 10,000 to the, and generally we consider that because the Earth is there, we consider that a pole from what is south to north. So means, or we have that equator there. So always your satellite is to be inclined with a north to south, or we can say that we can consider that is about the inclined with a whatever the equatorial plane. So orbits are inclined. Okay. So whichever the way, whichever the system we are using, so in this case, that orbit is to be inclined one. So we have a inclined orbit, and that inclined orbit that are useful for the purpose of a navigation, or we can say that useful for the mobile communication. So again, here in a medium Earth orbit, we require a multiple satellite. That we say that a multiple satellite is used to form the constellation. Okay, multiple satellite is used for the a constellation there. Same. Why constellation? Because earlier we have seen that a satellite constellation system in the LEO orbit, same is used. But here we say that number of satellite required are more. But if you compare with a MEO orbit, so in a constellation there are the less satellite is used in the, as compared to the LEO orbit there. Because a multiple satellite to be used, and that is they form the constellation. Because of the formation of a constellation, so we can use this for the navigation purpose or a mobile communication. And that orbital period of a satellite, it is nothing but what? Period vary from what? 6 hour to 12 hours. Earlier it was 90 to 100 minutes. Now here it's about a, it takes a 6 hours or a maximum up to 12 hours for one rotation. So this MEO orbit is used for this global positioning system. Application of this MEO orbit is nothing but a in a global positioning system. Now we know that a GPS system launched by the US, that GPS system launched by the US, they are using the MEO orbit. And in that case, each satellite will rotate. Means you can say that one period is of a 12 hour. So one period of a 12 hour for complete how many satellites require in this particular GPS system. They say that they require a 24 satellite. Okay, they require a 24 satellite, and out of the 24 satellite, 21 is in use, and a 3 for a spare. 3 is in a spare there. And they have the 6 orbital pair. They have the 6 orbital. Okay, so now we can say that in a 6 orbital plane, that 24 satellites are present. Okay, that is about a MEO orbit. Application of the MEO orbit is about what you can say that useful for the navigation. The next is about a polar orbit. Now, a polar orbit is nothing but what? So there will be an inclination of what? A 90-degree. There will be a inclination of a 90-degree. Means inclination means what? That is the equatorial plane and a orbital plane. Now we can say that a Earth here, and for the Earth, this is about your equatorial plane. Okay, this one is about a equatorial plane, and we say this is about a north. This one we say it is about a south. And for this north and south, we have the orbit likewise. So means this one is a orbit of a satellite that is inclined with a orbital plane is inclined with a 90-degree. Means inclination angle of this orbit is a 90-degree with respect to the equatorial plane. So means that orbit is from what? A north to south. It looks like a satellite. If you see that satellite orbit is present in the that on this particular poles there from north to south poles, and these particular satellites are used for the earth observation or for the communication or for the surveillance purpose. Now this a polar satellite, or sorry, polar orbits, these are the satellite present in this particular polar orbit. This means all the satellite will rotate in a north to south. Okay, it is moving in a north to south. So this particular satellite is useful for the earth observation. Used for earth observation. It can be used for the communication. It can be useful for the surveillance. Okay, so now we can consider that whatever the earth we have, so that orbit will be inclined from the north to south. Okay, so means your satellite will be in the given orbit there. It is always, so it is supposed to be, I redraw here. Now I am going to consider this is nothing but the earth now. And for the earth, this is only the north and south. How your polar orbit will be looks like? This orbit will be looks like. This orbit will be looks like. Okay. So means your orbit will be looks like. This way, your orbit will be looks like. Means your orbit will be looks like around the Earth. That's the word from the north. So means it takes a revolution in a given polar orbit. Over the that orbit will be over the poles. Okay, that is about the north to south pole. So that's why because of it takes a revolution in a polar orbit. So that's why the name of this particular satellite is that particular orbit is called as a because satellite takes one rotation on this particular polar orbit. So that's why it's called as a that orbit is called as a polar orbit. Means we can say that this one is about your orbit and and this one is about your equatorial plane. Now the inclination will be always it is about a 90-degree. Inclination it is always a 90-degree. So, but now we could not say that suppose how much is the time taken by this satellite for rotating the one particular period. But if you see the satellite, if it is present in the polar orbit and it is useful for the Earth observation or a communication or a surveillance there, so in that case, a polar orbit having the period of what? A 90 minutes. Okay, that is about a 90 minutes. Now, how much is the means its orbit will take a 90 minutes for the rotation. So that's why if suppose constellation of a satellite are used to cover the whole Earth, so how many satellites required in this particular polar orbit there? Suppose we consider that this there is a difference in this, okay, difference in this what you can say incline that orbit there, that position of this particular satellite. So means each that orbit, so here they are separated by some particular angle. This one we can say if they have satellite have the inclination of what, or we can say in terms of a separation of a latitude of what, a 22.5 degree. Okay, that is about the separation of a 22.5 degree. So there will be we can say a geographical that separation on this particular equator. So this is about our equator and there will be a geographical separation of this particular orbit there. So that is about your polar orbit. Next about a sun synchronous orbit. Now the word it is about a synchronous word. So generally we say that a satellite if it is a inclined satellite present in the inclined orbit, so then what happen? So that satellite will trace the earth that satellite that trace the earth surfaces in a several revolution. So it requires a multiple revolution to cover that particular earth surface. Okay, or cover that particular area. So generally we say that here we say a earth and we can say this particular orbit. Means we say that here it covers this particular area. So it takes one rotation. I can say that it takes one particular rotation for the cover this particular earth surface. So we require a, to cover the complete surface on the earth. So we require a multiple revolution to consider this. So means this one is a particular span or particular area is to be covered by the satellite there. To cover the full span or particular area, so it requires a one particular rotation. Okay, so whatever the rotation of the satellite. So Earth is rotating, which we can say that is about the Earth is taking a 1 day for the rotating around its axis now. Okay. Suppose a satellite is a fixed now, and if your that Earth is rotating around its axis, so again it will come back to that particular point or particular position after 1 day. Okay, it takes a 1 day. If we arrange this manner, if the orbit is arranged in such a way that satellite will scan this Earth in one particular solar day. Okay, in one particular solar day. So that means that particular point scanned by the satellite in one particular solar day. And that means what we can say now this particular spot here, now when Earth is rotating, this Earth is rotating around itself. It takes a one day. So means when it rotates, means this particular point will come back at that particular point. Means it takes only a 1 day there. Means same spot. It will come at after same time. Means just like it's supposed to be uh, in the afternoon. If it goes outside and at that particular time, your sun will be there on your head. Okay, there is no shadow seen. Now slowly, if supposed to be Earth is rotating, now your shadow appears. Okay, shadow appears. Now again in next day, you find out what point that again shadow will come on your overhead there. Oh, sorry, that sun will come on overhead and shadow disappear. Means shadow will be there behind, okay, exactly below you. So that is the time. Means we can say that that particular point on this Earth means it takes only a particular one solar day, or you can say that in terms of a solar time, we can say. And such type of a orbit, that orbit means this particular orbit means that particular point will come after one particular day. So that particular type of orbit, which is called as a sun synchronous orbit. Okay, that point will come again after 1 day. That is called as a sun synchronous orbit. Next about a, so we can see that I think